Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are starting, just as we started the last video, with sunset on the 3rd of March. But we're going to be looking at the lunar eclipse that's happening on the 3rd of March, which isn't visible from here in Ireland. So we can see the full moon here, and it is 99.8% full. As we go through the night, it drops down to 99.7 and eventually down to 99.4. If we come back a day, there we are, 99.9% full until the sun sets. And if we come back, it drops down from 99 to 99.8, 0.6, 0.7. We don't get to see the moon 100% full, though we do get very, very close early in the morning of the 3rd. So we'll come forward to the morning of the 3rd there again. There's the moon at 99% full, just as it is setting in the morning. So we will get rid of the atmosphere and the ground to start with, so that we can keep following the moon under our horizon until it reaches 100% full. So here is the moon 100% full. It won't be visible from Ireland because this is happening just about 10 to 9 in the morning for us here in Ireland. And there is the moon getting eclipsed, and a total lunar eclipse even from our latitude here in Ireland. And the eclipse finishes up by just about 1 o'clock in the afternoon here in Ireland, before the moon comes back up again. So we can see that this is a total lunar eclipse. It's a really good one. Even from our latitude here in Ireland, we can see the really dark part of the Earth's umbra coming across the moon. The entire moon is red. We're not seeing any part of the moon that's only covered by penumbra. We're not even seeing the edge of the moon or part of the moon with that kind of bluish tint that the edge of the Earth's shadow has. We can see it here. The red portion of the Earth's shadow is really closer to the center of the Earth's shadow. The edge does have this sort of bluish color. So we can see that this is a really good lunar eclipse. It lasts for quite a while. The moon is entirely covered. But for us to see this, or for you to see this, really, I'm not going to get to see this given my location, but in order for anyone to see this, you need to be in the right location, the right part of the planet. So to start with, we will head to the moon and look back at the Earth to see what will be, from the moon's perspective, a solar eclipse. The sun is going to be blocked out by the Earth. The Earth is going to get in between the moon and the sun. So here we are, we can already see it starting to happen. There's Saturn and Venus, Mercury, Mars, and the Earth just about to come in front of the sun. And we can see that the Earth takes up a much bigger portion of the sky from the moon than the moon does from the Earth. So we can see that the sun is passing behind the Earth completely, and it stays behind the Earth for quite a while, given that the Earth takes up a much larger portion of the sky from the moon than the moon does of the sky from the Earth. The ratio is very different. Instead of the moon and the sun appearing very similar in size, here the Earth and the sun appear very, very different in size. Now, unfortunately, we can't look at the Earth here to see what portion of it is directly in line, directly facing the moon. We can't see which portion of the Earth would give the best view. And if we go to the sun and look back at the Earth, which we will do, we will very quickly go to the sun and take a look back at the Earth if we can. Here we go. The moon will be, okay, we've got, apparently we're on the wrong side of the sun, that's okay. The moon will be directly behind the Earth, so we won't get to see the moon, and we'll get to see the location on Earth that is directly opposite where this eclipse will look best. So we can see here, Africa, the middle of Africa. We want to go exactly to the opposite side of here, just over to the Pacific. That's where we should get our best view. So we'll come back to the Earth to start with. Here we are. Really, it's the opposite of here. And of course, with maps, these projections can be a little bit tricky to get exact, but we'll go with the very, very middle of the Pacific. That seems like the most likely location for this to work. So let's pull back so we can get a fuller view of the sky, and we may need to... No, the land is back, the atmosphere is back, so that all seems correct. And we'll zoom in on the moon. for this total lunar eclipse. So here we are from the very middle of the Pacific, seeing the entirety of the lunar eclipse. We can see the shadow of the Earth moving onto the moon and moving off of the moon from this location. Because lunar eclipses last so much longer than solar eclipses, they're visible from a much larger portion of the Earth. And really, this is the bit you want to see. Seeing the shadow slide on or slide off of the moon isn't really the impressive part, and it is nice to see the entire lunar eclipse from beginning to end, but really seeing any complete and total portion of it like this is good enough, and that's going to be achievable from a large portion of the Pacific, much larger than the amount of the Earth that any given solar eclipse would be visible from. So we're going to hop over here to the eastern coast of North America, and there's the moon in the Earth's shadow, looking eclipsed, and we can see quite a good portion of the eclipse. We can definitely see up to the end of the eclipse there. We'll come back and see if we can get to see the very beginning of the eclipse. We can. So essentially the whole eclipse is visible from the northern part of North America as well, and we can see the entire moon looking red. So that's one side of the Pacific. We'll hop over, hopefully, to the other side of the Pacific. Here we go, which would be just over here in this direction. Now I think that the peak of the eclipse might be a little off the center of the Pacific, so it might look a little bit better from the west coast of North America. We're going over to the opposite side of the Pacific here, just to see the lunar eclipse again. So from either side of the Pacific, this is going to be visible. Here it is beginning. Or there it is ending. No, there it is. Yeah, there it is ending. We're moving back in time to see how far, if we can get back as close as the beginning. There we go. Complete, total lunar eclipse. The entire moon looks red, a blood moon, and the moon passing back into visibility again. And we can see that penumbra just from the very, very beginning of sunset there through to a little bit before sunrise if you're in Japan. So while we're looking at this version of the eclipse, here's the moon without any portion of the Earth's shadow on it. The moon is completely exposed to the sun. If we move forward, in fact, we might be able to see it happening up here. So we can see its magnitude 0.21, and we're seeing it at magnitude negative 12.98. So that means the moon really isn't that bright, but we're seeing it particularly bright because it's particularly close to us. If we move back to the eclipse, the Earth's penumbra will come onto the moon. There it is. And we can see the magnitude going down, the apparent magnitude, how it actually looks in the sky. We can see it getting, technically it is getting smaller. The number is getting smaller. It's going down here. And these are negative numbers. So they're getting closer to zero, which in this case means that it's getting fainter. If we keep moving, we will see all of the Earth's penumbra on the moon, and then the umbra will make contact, bringing down the brightness of the moon even more until it's completely in the Earth's umbra, and we can see it there, magnitude 1.5. So that's a difference of 12 magnitudes, nearly 12, we'll say 11 magnitudes. 11 stellar magnitudes, or this magnitude that we use for measuring the brightness of things in the sky. Of course, this is lunar magnitude really, because we're looking at the moon. We can see how much fainter it's after getting. It's still visible. There is still light, this kind of reddish glow that's passing through the Earth's atmosphere. There's still light coming from the moon. It's still going to be visible compared to the blackness of space. So we can see there the moon at a full 13, minus 13 magnitude, so very, very bright. The penumbra coming onto the moon, reducing it down to just about 12.5 there, and then the umbra reducing it down way, way further. We can see once the last bit of the moon gets blocked out by the umbra, there's a precipitous drop from about magnitude 10 there, you know, and then let's say even here magnitude 9 with a tiny sliver of the moon still visible, magnitude 8 with a sliver of the moon still visible, and then suddenly it drops down to magnitude -1, much, much fainter. So this is the lunar eclipse. This is the lunar eclipse that we're going to miss from here in Ireland, because it's happening for us pretty much in the middle of the day. We can see it happening for Japan here at just about midnight. For the middle of the Pacific, it'll happen, or we can see it happening at just about 9 o'clock here for Japan. From the middle of the Pacific at the peak, it should be happening at exactly midnight. But for us here in Ireland, that means it's happening at exactly or nearly exactly midday. So I hope that you get to see this lunar eclipse. It does seem like it will be a particularly good one. If you don't get to see this lunar eclipse, don't worry, you've already seen a preview of it here. If you enjoyed this video, then please do like it. If you like this kind of content, then please subscribe to my YouTube channel. And if you'd like to read some of this information, you can head to my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.